In this video, we're going to continue to look at examples of solving absolute value equations. This time the equations are a little bit more complicated than the ones that we saw at the beginning of the lesson. And if you look at example 2, you see a couple of things that might make this more interesting. The first one is that we are multiplying x by 3. In the previous examples, we just had x minus 1 or x minus 4. The second thing is that at the end of the equation, outside of the absolute values, outside of the absolute value bars, we're also subtracting 10. So these two things are going to complicate it a little bit. And I want to first point out then a note here. And that is that we're going to isolate the absolute value before we set up the two equations. So that's going to be very important here. We want to isolate the absolute value before setting up the two equations. And what we would do in example 2 is that we would add 10 on both sides. Now some people may look at the original equation and say, hey, that's an absolute value and it's equal to a negative number on the right. But we have to reiterate that it's an isolated absolute value of x, can never equal a negative number. But what we see in the original equation is not an isolated absolute value of x. And in fact, when we go about isolating, it no longer will be equal to a negative number. That may not always be the case, but it is going to be the case here. So we get absolute value of 3x plus 9 is equal to 6. Now we're ready to set up two equations. And we would get 3x plus 9 equals 6, and 3x plus 9 equals negative 6. From there we subtract 9 on both sides and we get 3x is equal to negative 3. Dividing both sides by 3, x is equal to negative 1. And so that's one of the values that satisfies this equation. The second equation, subtract 9 on both sides, we get 3x is equal to negative 15. Dividing both sides by 3, x is equal to negative 5. And so these are the two values of x that will make that true. Now, we can construct after the fact an equation. The fact that we're multiplying by 3 times x plus 9 makes this a little bit more complicated to graph at the beginning. But we can graph from the end here, and that is we would start off by plotting our two answers. Remember, the one on the left is negative 5 and negative 1. We can add negative 5 and negative 1 together. Divide by 2 would give us negative 6 over 2, or negative 3. That would be the center. Then the distance from negative 5 to negative 3 is 2. The distance from negative 3 to negative 1 is also 2. And from this point, using our structure, x minus the center is absolute value of that is equal to the distance from the center we can now come up with the equation that says x minus negative 3 is equal to 2. Oops, missing an absolute value bar there. But we know that x minus negative 3 is the same as x plus 3 is equal to 2. Now you might look at our final equation and where we started from, and you might see that they are different, yet they are equivalent. If we were to divide every term in the initial equation by 3, 3x divided by 3 would be x, 9 divided by 3 would be 3, 6 divided by 3 would be 2, and you would come up with an equivalent equation, and much simpler, of absolute value of x plus 3 is equal to 2. So this is an example of a multi-step absolute value, multi-step absolute value solving a multi-step absolute value equation, because solving any absolute value equation involves multiple steps. Next, what we have in example 3 is a word problem, but with absolute value word problems, we're going to be given the answers, and our job is to construct the equation, as opposed to being given an equation and solving it for answers. So in this example, we have that in a cheerleading competition, the minimum length of a routine is 4 minutes. So if I were to graph minimum length 4 minutes, the maximum length is 5 minutes. We want to write an absolute value equation that represents the minimum and maximum lengths. So what's the first thing we do? We need to find the center. So we add 4 plus 5. We need the average of those two numbers, divide by 2. We get 9 over 2, which is 4.5. And that might be easy to tell without doing that 4.5 is halfway between 4 and 5. The next thing that we want to do is to find the distance from the endpoints to the center. And we can see that the distance from 4 to 4.5 is 0.5. The distance from 4.5 to 5 is also 0.5. And from that, we can use our structure x minus the center, absolute value, is equal to the distance from the center. Alright, now we just have to put the pieces together, and it goes absolute value x minus the center, which is 4.5, is equal to the distance from the center, which is 0.5. Now, we're done. That is our answer. Some people might think that we need to solve this equation at this point, but if we were to solve it, we would actually come up with the two answers of 4 and 5 that we had from the beginning. So let's just see what that looks like. So again, with an absolute value equation, we're going to isolate first, which we have, and then we're going to set up two equations, x minus 4.5, and that's equal to negative 0.5. Solving, we add 4.5 to both sides. When we do, we get x is equal to 5. Adding 4.5 to both sides, negative 0.5 plus 4.5 is equal to x equals 4. So as I said, we don't need to solve this because we were given the answers at the beginning, and our job here was to construct the equation only. Okay, we're going to move on to some examples then that you can do by yourself to double check your understanding of this material. Okay, so in example 4, we have the absolute value of x minus 2, then plus 5 is equal to 9, and we've learned that we need to subtract 5. We need to isolate the absolute value, and we do that by subtracting 5 on both sides. We get x, absolute value of x minus 2 is equal to 4. From that point, we set up two equations. X minus 2 equals 4, and x minus 2 equals negative 4. Adding 2 on both sides, we get x is equal to 6. Adding 2 on both sides, we get x is equal to negative 2. When we go to set up a number line, we have negative 2. and positive 6. We can find the center by adding negative 2 to 6, and we'd get positive 4. Dividing by 2, we would get 2. So the center is 2. The distance from negative 2 to positive 2 is 4. The distance from 2 to 6 is also 4, and so we would end up with the equation absolute value of x minus the center is equal to the distance from the center. The distance from the center being 4, and that would bring us back to our isolated equation. In the second example, we have 4 times the absolute value of 2x plus 7 is equal to 16. And so here, again, when you're multiplying by something, I'm going to suggest that you don't distribute, but instead we're going to divide both sides by 4. When we do, the 4's on the left cancel, the 16 and the 4 cancel to give 4 on the right. And so now we have absolute value of 2x plus 7. Again, that's not 12x, but absolute value of 2x plus 7 is equal to 4. Setting up two equations, 2x plus 7 is 4. 2x plus 7 is negative 4. Solving by subtracting 7, and we get 2x equals negative 3. Dividing by 2, we get x is equal to negative 3/2. Now I'm not going to ask you to graph this type because there's a number times 2, and everything doesn't divide evenly. So we're not going to get that complicated at this stage of the game. Solving the second equation, we subtract 7, and we get 2x is equal to negative 11. Dividing by 2, x is equal to negative 11/2, and so this would be either negative 1.5 and negative 5.5, and those would be sufficient as our answers for the second equation. Finally, the third equation, we have negative 2 times the absolute value of 5x minus 1 minus 3 is equal to negative 11. We're first going to subtract, or rather first going to add 3 to both sides before we divide. And so I add 3, and I get negative 2 times absolute value of 5x minus 1 is equal to negative 8. Then I'm going to divide both sides by negative 2, and I get absolute value of 5x minus 1 is equal to positive 4. Make two equations. (5x minus 1 is equal to negative 4), and we end up with adding 1 on both sides. 5x equals 5. Divide by 5. X equals 1. Add 1 to both sides. We get 5x is equal to negative 3. Divide by 5. Divide by 5, and x is negative 3 over 5, or negative 0.6, and that's going to be sufficient for that answer. Then I'm going to scroll up next and solve problem number 7. With number 7, we have a poetry contest where the minimum length of a poem is 16 lines, the maximum length is 32 lines. So I set up my number line, plot the 2 points. I find the average to be 24. Then I calculate the distance away from the center to be 8 on both sides, and I'm ready to complete this as absolute value of x minus the center equals the distance from the center, and I'm done with that. So that will conclude this lesson.